Welcome back, ladies and gentlemen. Today we're going to be talking about reasoning with properties of algebra. So let's take a look at some of our basic properties and then put them to good use. So our algebraic properties of equality, the neat thing about this is that you guys have been doing this for many, many years. Okay, you really have been. So it's nothing new. What you're going to be doing is the things you normally do to solve equations, you're giving reasons behind why you're doing it now. So first thing we're going to take a look at is let A, B, and C be real numbers. Now these again are variables, okay, so they can represent any kind of number, specifically a real number. So for the addition property, if A equals B, then you are allowed to say A plus C equals B plus C. Okay, now where have you seen this before? Well, here's a side example. X minus 3 equals 5. So there's an equation. X minus 3 equals 5. If you wanted to solve this equation, you know that in order to solve it, you need to get that negative 3 to the other side. The opposite of minus 3 is 2 plus 3. So I can plus 3 there, and then I get x equals 8. So the whole trick for all of these is you are maintaining your equality. What you do to one side, you must do to the other. So for subtraction equality, as you might have guessed, if A equals B, then you are allowed to subtract a constant from both sides. Okay? How that would look a little differently, okay, is you would have something like x plus 2 equals 8. Okay, what could you do to both sides? Well, I could subtract 2, x equals 6. So again, nothing new for you. It's something that you've already done before. Multiplication property, if A equals B, then AC equals BC. Okay, you are allowed to multiply both sides by a constant. For this particular example, you could see something like x over 3 equals 6. Okay, well, the opposite of dividing by 3 is to multiply both sides by 3. So I would get x equals 18. Cool. Division property, this one's kind of important. You will see this one quite a lot. If A equals B and C does not equal 0, then this is important, okay? Reason being is whenever I say A divided by C equals B divided by C, always keep in mind that you can never divide by 0. It's undefined, okay? So, as I mentioned, this one I know you've seen before. 5x equals 20. You may divide both sides by 5. X equals 4. Okay. Alright, so those are the big hitters, okay? Those are the ones that you guys are really used to. You've seen it time and time again. Reflexive property, however, these are your kind of newer ones, but you've, again, most likely seen them before. Reflexive property for any real number A, we can say that A equals A. Reflexive, think about reflection in the mirror. You're seeing yourself, okay? Symmetric property. If A equals B, then we could take this and go, boop, B equals A. Okay? Symmetric is just like, think about a book, you can flip it around. Okay? So reflexive, A equals A. Symmetric, A equals B, B equals A. Transitive, we're putting it all together a little bit, like 1, 2, 3. If A equals B and B equals C, can you see how they both equal B? Since A equals B and C also equals B, we can then say that A equals C. Now the way that I remember this, reflexive, symmetric, transitive, RST, 1, 2, 3. Okay? So we got 1 equal sign, 2 equal sign, 3. Substitution, if A equals B, then A can be substituted for B in any equation. Again, you guys have done this before. So for example, let x equal 2. 3x minus 5, right? You could take 2, plug it in for x. You can solve your equation that way, or your expression in that case. Properties of equality along with other properties of algebra, such as the distributive property, can be used to solve equations as well. So, distributive, you guys should be comfortable with that. It's when you take something and just kind of multiply it in. So if I have 2 times the quantity 3 minus x, 6 minus 2x. Okay. So where are we going with this? Well, we're going to be doing our algebraic proofs. Okay. solve 5x minus 18 equals 3x plus 2 and write a reason for each step. So given, statement given, first problem given. Now, how do I go from 5x minus 18 equals 3x plus 2 to 2x minus 18 equals 2? Well, look at the above line. This individual subtracted 3x from both sides. So if I'm subtracting from both sides, that's the subtraction property of equality. Okay, good. So now I want to look at my next step. 2x minus 18 equals 2. How do I go from that to 2x equals 20? Well, what did they do? Well, they had to get rid of the negative 18. The opposite of minus 18 is plus 18. Or sorry, plus 18. So that's known as your addition property. Make that a little better. Okay, and then finally, to go from 2x equals 20 to x equals 10, we are dividing both sides by 2. Okay, division property of equality. Wonderful. Okay, let's get to our back. So here it says, now it's the same idea, except now they want you to draw out your own statement of reasons. So I'm going to make a T-shaped table. Okay, the top here I'm going to write statements. And then over here I'm going to write down reasons. Now when you guys write out a proof, the first line will always be you write down the problem. 3 times the quantity 4x minus 1 minus 8x equals 17. Okay. The reason for that is given. You can't solve a problem that's not given to you. Okay? It's a minus there. My apologies. Now, the first step that we would like to take a look at is we're going to multiply this 3 into the parentheses. Okay, what's that known as? Well, that's your distributive property. So if I multiply that in, okay, 12x minus 3 minus 8x equals 17. Distributive property. Okay, now, from here, there are multiple steps we could take. I'm going to combine the 12x minus 8x on the left-hand side. All right, so 12x minus 8x is 4x. When you're doing that, that is known as simplifying. Okay, you're combining like terms. If you would write down combine like terms here, that'd be wonderful as well. Okay, our next step, how can I get 4x by itself? Well, I can move that negative 3 over by adding it. So 4x equals 20. That's your addition property of equality. Okay. And then finally, we can solve this by dividing both sides by 4. Okay, cool. There is a wonderful algebraic proof. Every single statement has a reason. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, all is well. All right, number 3. The table gives the heights to the top of the first few layers of bricks in a brick wall. Determine the height of 18 layers. Now, here's my foundation. Okay, that's where I'm starting at. When I add 1 layer of bricks, it goes up, the height goes up to 9 inches. When I add 2 layers of bricks, the height goes up to 12 inches. So we want to try and find the difference each time. So to go from 6 to 9 is plus 3 inches. To go from 9 to 12, it's plus 3 inches. Plus 3 inches. Plus 3 inches. So you're noticing a pattern here. Now you could, if you really wanted to, I could take my graphing calculator, okay, and I can go, all right, I want to know the 18th layer. Well, I can do 6 plus 3, okay, that's 1, 2, 3, 4, 5, and I can keep doing this. But hopefully you guys agree with me that's kind of annoying, okay? So instead, I'm going to come up with an equation. I know that my height in inches, okay, is equal to, how much is it changing each time? Well, it's going up 3. So 3 times the layer And what was my initial starting point? Boom, plus 6. Okay? So, now that I have this equation, I want to know when it's the 18th layer, y equals 3 times 18 plus 6. Okay? So y equals, let's go back to our trusty calculator. Okay? So we've got 3 times 18 plus 6. We're looking at 60 inches. And all is well. Okay? So, all is good. If you have any questions, please feel free to ask. As always, keep up the good work, and good luck. We're all counting on you.